So list and all we will be using when list vector and array. Okay, array is mutable, you can change it. So array has the different use case. When you want any mutable uh, collections, that time you will be using array. List and vector is also kind of similarly how we are representing list, the similar way we are representing vector. But if you have to access the elements using the index like 0 1 2 3 something like that, that time you will be using vector.
Okay.
Set you will be using when you have when you want all the unique element in the set. Okay, and faster access. When you don't want any duplicate, that time you will be using the set. Map, like map will have key value pairs, we'll see that how it has key and value. Okay, so that time you will be when you have any requirement of key and value, that time you will be using map. Okay, so these are like a representation of list, vector and array are kind for all of them are like similar. For the set also it is similar, just difference is like set has a unique element, but list, vector, array representation is kind of similar. The operations and all are also almost similar, but the thing is like when to use which. Okay, so vector you will be using when you have the index x, when you want to access your element based on the index like 0 1 2 3 4, right? So on that case you will be using vector. Array when you have immutable. Okay, like when you have your mutable collection. List when you want ordered and immutable, that time you will be using the list collection.
That 0 1 2 3 index can't be using list.
No, list also we can you can use. In the list also you can use. In the array also you can use. But if when given all the three options, you should use vector because it will give you fast random access. Means it will perform better than list and array when you have the large data set, okay, and you have indexed data set.
Okay.
Okay. Because it is fast access because of its internal structure. Okay,
Okay.
internal structure, how back to vector is, because of that you will be able to access it fastly when you want to access with the index data. See, you can access the with the index list also and map all array also. But if you have such a requirement, then you should use the vector.
Okay.
It will be faster if you compare with the list and all.
Okay.
Okay. Now let's just look at the examples of list. Sorry, not for the vector also. If you have to represent vectors, you can represent like this is vector representation. So by default, all the thing like other than array, all other are immutable, but only the array is mutable.
Okay.
In this way, you can represent the string, sorry, integer. You can see that here is a vector of integer. Similarly, if you have to represent a string, you can use the string. Now from the there is one range. Let's suppose here I have given 1 to 5. Okay, in this way. Other way to represent the range from like 1 to 5 or anything continuous range, you can write. Let's just create one range vector. 1 to 6. Okay, here I have created 2 5. Let's just write like this. 1 to 5 dot 2 vector. Okay, it will create like this. See, there are other options also. Okay, it will give the array. See, for as I told you, most of the things it will be similar.
Okay.
Operations and all are similar to all of most of these operations. There are some here and there changes. Okay, but most of the places we will see operations are same. Okay, if you see here, right, and also if once on the Scala, one thing is good is like once you give the dot, it will show you that what all operations it support. In that we'll understand that. But more or less, I would suggest you try to remember, because in interview and all, okay, people will ask you.
Okay.
You can see, right, it support the array, buffer, list, map, sequence, stream, vector, parallel array. Okay. Now, there is one more thing, fill. Okay. So what it will do, let me just write first program example for it, then I will explain. You see here, right, if you want to repeat any element and print it, or maybe you want to store some repeated element, okay, then you will give your syntax will be something like you can use the fill. So fill in the number of time you want to repeat and the element whatever you want to repeat.
Okay.
Okay, similarly in the other also, I think this will be present. See, in the list also it is present. So as I told you, for all the collections, mostly the syntax will be similar. If not all, then at least 90%. So in this way, if you want to repeat element, you can use it. There is one more, which is tabulate. So for the similar, like you have to use the vector dot tabulate. And in this case, if you want to, here you have to write one function, what you want with that element. I'll just write on it. What tabulate will do, see here what fill was doing, it will just printing the whatever element you are giving, it will just giving you that as a collection, that many time number of time you want in the you write in the fill. In tabulate, whatever you write, okay, it will start from a range like 0 to till the number whatever you want, okay, and it will apply that function on it.
Okay.
Let me just write one more. Let's suppose here I am multiplying it with 1 and 1, okay. So your output is 0, 1, 2, 3. So
Yeah.
4 with the index it has given you. Here what you are doing, you are multiplying n by n into n. Okay, so whatever element it is giving you, you are multiplying. So 0 to 0, 0, 1 into 1, 1, 2 into 2, 4, 3 into 3, 9. Okay, so tabulate is like whatever you will here in the fill, you are just printing or storing this element, whatever you can here you will store it from by the index and it will implement whatever the function you write here.
Okay.
Now you have similarly, if you have one vector, let's just consider we already have here, right? Now you can access the element how you are accessing in the other element, so you can access it. And similarly you will have all the things whatever you have like head, tail. So what tail is doing? Tail is,
Last one.
yeah,
Of
it will just leave
remove the first one. Yeah.
first element and it will give you all. And so as tail is doing what, giving all the element but not the last, similarly there is one init. What it will do,
First element.
It will give you all element, not the last.
Okay, last. Okay.
Tail will give you all the element, not the first. Init will give you all the element, not the last.
Okay.
So similarly here also we have that length and all. Okay, it will give you the length. Then you can check it whether it is empty or not. Those things. So it return you false because it is not empty. Now similarly how you were appending into the okay, is it not the correct syntax? Oh, okay. I want to add in the beginning, right? So I have to give here. See now I added one element on the beginning, so it is like this. So the syntax will be plus, then colon, then b. If you want to add the int, then colon, then plus. What your plus will be throughout the element size.
Okay.
So this is the things, and also like in the list also you can concatenate with the double plus. Okay, if you want to add some new vector to it. So it is added. Okay, so I think these are the some of the things, right? If you want to update also here, okay, you can update like v dot update. It will you can update it with index. Let's suppose your vector is this, right? Uh, you have added v2 plus plus.
This tail, init, and all will be there in list as well, right?
Right. In most of the element, in most of the collections, you're like at least in vector, list, and array. Okay, both are kind of similar representation, and whatever you can do in vector that can be done in list also. It is just in the array is mutable, list and vector is immutable, and wherever you have to access on the basis of index, okay, that time you will use the vector because it will give you the faster.
Access data.
Yeah. So here you can see, right, V is 1, 2, 3, 4, 5. Now let's just what I want is like I want to replace 2 with some element. Okay, let's replace 2 with 2000. So index I will give 2 and the element what you want to replace. So it changed to 2000. Now if you see one thing here, we are doing V plus plus and vector and all, right, but still my V is vector is only this because vector is immutable. Okay, you whenever you are adding element, it is creating new vector out of it. It is not updating that. If you see your vector is always the same 1, 2, 3, 4, 5. Right after you do it some operations also, still your V is same 1, 2, 3, 4, 5 because where it is immutable, you cannot change it. All the time, whatever you if you are adding anything, it will create new vector out of it. It is not updating the existing vector. Okay. Aggregation and all, I think we have seen or not yesterday. But if you want, like, let's just you want to check or you want to get the sum, I think yeah, sum is there. Let's suppose you have element 1, 2, 3, 4, 5, right? You want to get the sum of it to give it the 15. If you want to get max of it, which is a max element from that, you can get it 5. If you want mean, you have like this. Okay. Now let's just you want index of any element, okay? So let's just you want to check what is the index of element 2, okay, in your, or let's just take index of 3. It should be 0, 1, 2, right? It returned 2. Okay. So yeah, these are the operations which you can do, and I think almost all of the not all the 90% of these will be similar. Maybe some few will be different. Okay, so that you have to check. Now let's just come to array. So similarly, how you have let's see if you can think for the theory in array. Okay, as I told you, like, okay, one more thing, it is fixed size. Okay, and mutable. You have to define the size also. Okay, it is a fixed size, mutable, fast index access, and used when mutability and performance are needed. So as I told you, right, whenever you need performance and accessing it with the index and all, you should use it, because that time it will give you the faster access. The reason being its representation, how it is represented in the internal tree structure. Because of that, you will get the faster access on the okay, and the sorry, in this is about the wait. This is about the vector where you get the faster access based on index. Here also you will get the faster access, but if you want any immutability in your collection, then you will use it. Got it? So the
Yeah.
difference between array and vector is like,
Mutable, immutable.
right? Yes, you can see the slides, right?
Slides I'm not able to see.
Okay, but anyway, not an issue. I told you about the array, right?
Yeah.
And okay, nothing in the array. Let's just look at the example. Okay, then we'll look at map. So you understood the difference, right?
Yeah.
Between the and the, it will be similar how it is in all the places. Similarly, you can create the array of like 1, 2, 3, 4, 5. Yeah, it is by default it is mutable. Sorry, you were
Array
asking.
is, array is mutable.
Right, yes.
Okay.
Let's just write some of its example. 1, 2, 3, 4, 5. Now you can access this element similarly how you are doing in the
I have
element.
one question actually. In previously in vector, we have given like 1, 2, 3, 4, 5 values as a list, and we try to update, add something in the before the head tail we have used, right? So there we are changing the data. So
No, no,
it means
that's what I told you, right? We are changing the data, but it is creating new vector out of it.
okay, 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 fine, fine.
It is not changing. That's what I showed you, right? Like
Yeah,
it
yes, yes,
one your vector is always 1, 2, 3, 4, 5.
yes, yes.
See, whenever we were appending, okay, I printed here V, right? If you see, this, your vector V is 1, 2, 3, 4, 5. Then you tell in length empty till here you did, right? Now you are doing well in V, you are adding element. See your vector you are added, then in that here also you added one element. After all these operations also, if you see your vector is 1, 2, 3, 4, 5, right here.
Okay, okay, yeah, yeah.
If you see your vector, it is still 1, 2, 3, 4, 5. Means it has not yet changed your vector. See your vector
Okay,
is 1, 2, 3, 4, 5. So whatever you do, it will create new vector out of it. Okay. So for the vector array also you will have similar thing like element, adding, removing, okay, length map. One more thing, let me show you one more one MK string, okay. Well, okay, if you want to there is one operation which we call as MK string.
okay.
V dot MK string. if you want to represent this vector in form of string, right, you can use the mk string. See here, I have given it is mk string and with the comma separator. I think separator you can change. See, whatever the separator you want, it can give you that separator. See, I have mentioned that give me the separator as hash, give you like this hash. And see the string, it is the data type, it is string, right? Whenever you have any list, any collection like list, vector, array, and you want to represent in the form of string, right, you use the mk string. So it will be similar. Then you have all the operation whatever we have seen, right? If you see, you will have all those v dot length, v dot till, we have v dot head, here we have max, we have min. So all the operation will be similar, no change. Yeah, you have we have still this fill, right? Okay, fill, this is, but array also should be supporting fill. Array dot, the syntax was like I think vector dot fill. So the array dot fill, and then in the similar way how you were giving like 3, and then you print like hello, you gave that time, right? See, it will give you that. So all the place, most of the syntax will be similar, as I told you, that tabular and all. There's no difference. Maybe there are something which is present in one and not in the other, that you can see. Okay.
Okay.
Okay. Let's just see how it is mutable. Okay. There when let's just access its element as I showed you, right? This can, you can access with the 0. Now let's just try to update its element. V dot update. Okay, and let's just update its element 1 to 2000. 1 to
Okay. We give val v, it won't get updated. I mean val means immutable.
yeah, val means immutable.
Okay.
But updated. Am I missing something with this? Okay, see here. You updated the V, right? With the 100. Now, if you once you are printing your V, see your V is updated. See the difference between vector. When I updated the vector and I print it, that time you have the same vector. But in the case of array, once you update the element, you see your array has also changed.
Okay.
Okay. So this is the difference between vector and the array and the list. It is if wherever you want to add and make any changes in the element, you can use the array. Now let's just move to the map. Slide in the map will be the key value pair collections. Okay. So you will represent your map. Okay, wherever you have you need key value pair collections, that time you will be using the map. And in your map, your this we call as the key, and this we call as the value, and your key will be unique always. Okay, your key means with that I mean that you can have the same multiple or let's just maybe create one again. So in this way you will represent your map. Okay, and it is immutable, and your key should be unique. Your value can be duplicate, but your key will be always be unique.
Can please come again
So
actually on
with
that.
that, what I mean is like, let me just create. I'm expecting that it should give you the error. See, I tried to, okay, it has not given you error, but it has updated the value. See here, this is the key, this is the value. Okay,
Okay.
this is the value. Once, see here, if you see, new map has two elements. Here, what I did, I am trying to keep the duplicate key. Your key is right, two places A, and I given a value 3. So in this case, what it will do, it will just update your value. It don't keep two same key. Here
Okay.
given two key, right, A, but it has just kept the last one, A equal to 3. Your key should be unique always. You cannot give is the duplicate key. This will the property of map that your key will be always be unique. Your value can be the same. Let's say I have given the VV1, okay, and here also let's just keep, let's shall give 2 here 1. If you see, right, in first element with A equal to 1, it will try to add the element, then it will try to add the B1, and then when you see A equal to 1, then again it will replace this. So that's why your output is this. And if you see the values duplicate, value can be duplicate, but your key should be unique.
Okay.
Okay. Now, if you want to add element to the map, to add element, you can do like, okay, with this, you can see that your new map has changed to, with the adding element, it has changed to A, B, and C. All the 3 has come here. So there are other way to create the map. Any confusion or anything?
No, I'm fine.
Okay, so there one syntax to create other syntax to create map is like using the tuple. Okay, let's just suppose let's just take the grade of a student. Okay, and there you keep the subjects.
Tuple is a list.
Yeah, that is the another kind of collection where you can store the element of different form. Like you can store the string and
Integer.
integer and doubles in only one collection, and then you can access it with the dot operator. We'll see the tuple. Okay, at the end we'll see. That's a different. Then we don't keep it in the collection, that we are just keeping out of it the collections, because it can store the heterogeneous elements. We'll see about the tuple, and tuple is also one important thing which we are using most of the time in the Scala. We'll see about that. So one way for now, you just understand that there is one way to create it, like using the, let's give the name as grade. And let's suppose that if I want to create something like this, then I have to remove it. See the difference between these two. You are, if you, tuple is this, okay? Once
Okay.
you element inside this small bracket, we call this as one, this is one tuple, this is another tuple, okay? Anyway, we'll read more about it. For see, but the difference, what I'm trying to show you that how you can create the maps. One way is creating map is like you can create like this using the tuple, or other way what we have seen here. See the similar, these both are the same data, everything is same, it just representation is different. Here I have used the tuple, here I have used the similar way of key value pair. You see the output of both are same map, here also map.
In output, we are getting like Scala dot collection immutable. That will come definitely.
Come again.
In output, we are getting like Scala dot collection immutable map string int like that, right?
Yes.
So that will come for every result.
No, here we are, it depends on in the internal representation for the list and all. I was not seeing these things, but map I am seeing. But whenever you write your programs and all here, right, you won't see these things. Here we are using the interactive element, interactive way of executing our code. That's why we are seeing.
Okay, okay.
Okay, so that's why the output is coming that way. In the way how they have represented internally, then that's why you are getting the output in this way. For the list, I don't remember that we have like that, right? List equal to. So it has only, okay, yeah, it has given you the list and data type also, but it has not given you the mutable or immutable kind of, okay. But here in the map, we have actually mutable map also. Okay, in the like all the list, we have two type, list, vector, and all the collections. We have mutable as well as immutable. But array by default is mutable. You can have the vector also, which is mutable. You can have the list also, which is immutable.
Okay.
Getting the things?
Yes.
So in the all the collections, like in the list, map, and then vector, and then set, you have mutable as well as immutable. But by default, it is immutable. If you don't give anything, it will by default, it will take the immutable. But in the array, by default, it will take the mutable.
One more thing, like in vector, if we use variable, it can be mutable. Is it mutable? Like val where?
No. It will see in the vector and all, it will create new
Oh, okay, fine.
vector out of it. But here it has in the array, it will update the same array.
Okay,
That's
everything is mutable, basically.
right. Yeah, array is mutable by default. See, we can have both mutable as well as, so in the collection you have both things, mutable as well as immutable. But you have to internally you have to call it, you have to import it. You have to import the see it now. Not the list, but for the list you have list buffer. Okay. For the vector, okay, for the vector, I think you have to use the array buffer only. See now, if you see, I have done this, right? Let me just get it. And instead of list, I will use the list buffer. Now this has become immutable. Sorry, mutable, because I have imported the collection mutable, and then I'm with the list buffer. Now I'm using it. Okay, but if I won't use, if I directly use the list, then it will be okay. Now you may tell that okay, for the immutable you have for the mutability you have to use the list buffer, but for immutability you have to use the list. But yeah, that is correct. But this is where we say that by default list, set, vector all are immutable. Only the array is mutable. Am I confusing or you getting the things?
Getting.
Or shall I explain again?
No, fine.
Okay, so you have in the collections, you have both mutable as well as immutable. But by default, if you are writing something, then the list, set, and vector, that will be immutable. But if you are writing the array, that will be mutable by default. If you want immutable array to be get, I don't think that we have immutable array. Let me just check immutable dot. See, we don't have immutable array. We have only immutable list, map, set, vector, right? See, we don't have, right? This is a, see, in the immutable collections, what you have list, you have map, you have set, you have vector. Okay, you have stream and all this. This we'll look at later. And now later, what are the in the immutable we have? For dot collection dot mutable dot. See, in the mutable you have set, mutable map, you have mutable list buffer, you have mutable array buffer. Okay, you don't have mutable vector. If you want to use the vector to be mutable, you have to convert into the array. So vector can be also converted to the array. Let me just show you. If you convert in this way, it will be this will become array, and now you can append the things here. Now, as soon as you convert into the array, this will become mutable.
Okay.
See here it is showing you for the this it is giving you scala.collection.immutable.vector. Here for this we only got the list. So it depends on how they have represented it internally, how they are printing it. Okay, so this is not under your control, and why it is showing is because the program internally have written some these vectors representation all in this way, that it is representing with the all full detail with the package collection scala collection dot immutable dot vector, and here it is only giving you the list. Any question?
No. Yeah. Okay.
What the difference?
Yes.
Okay, now let's just suppose how I can access the elements. Okay, this is the key and value. You can access the element how you were accessing in the list and all using the index, right? 0 and all. You can access
Yes.
the first element. So in here you can access the element by key. Let's suppose that I want to see what is the maths number. Okay, they can. I can access it by key. Say grade maths, it's giving me the 90, number 90.
In array. Okay.
Not in array, in map.
Sorry, yeah, in map.
In map, you can access the element by key.
Okay.
Okay. In map, what are the properties? Your key should be unique. Your value can be duplicate, right? You can represent in the tuple way or in the this way, key value way you can represent the map. If you want to access the element of your map, you have to use the key to access the element. If you want to get all the keys, I think there will be some, yeah. See, grade.key will give you all the keys. So it gave you maths and English, right? And see,
Yeah.
one more thing, see, it is giving in the set. Why? Because your key will be unique. Set is the unique, set will contain only unique element, right?
Yes.
So that, see, once you try to see the grades key, let's just look at the grades value.
There can be duplicate.
Right. See, here it is giving you the set, and here it is not giving you the set because it can have the duplicates, but anyway, you can see, right? It has the duplicates element. So if you want, you can see the keys also, values also of the element. If you want to just get all the keys, then you can get the keys and value. I think it has max, mean also. If you want to get the key max, so it give you maths because M is greater than E in the alphabetically. That's why it has given you the max as math. And the number in the both the place minimum number is 90. Let's just make it 91. So it represented here the minimum value from the values 90 and 91. The minimum is 90. One operation is like, let's just see what we can see. Grade dot, if you try to get the grade dot mean, it will give you the minimum of the key values. See here, I try to get the minimum of key, right? It give you the English because English is the smaller than maths. If I try to get the max, it will give you the math first. Getting these things or not?
Yeah, I'm getting it.
Okay. So now let's just suppose I want to check whether that element there is one contain, I guess, yeah, there it is contain. See, in the contain, you can what you can pass key. If you pass here, let's just pass the maths. It will check whether maths is present here or not. It is true, right? Let's just give math one. Math one is not present, that's why it is return you false. You can check its size of the map. There we were using the length in the string, not in the string, but in the list and all, we were using the length to get the size. Here I'm using dot size to get the size. Getting it?
Yeah.
Okay. If you want to, let's just suppose that you want to iterate through it. How you will iterate on the list and all? Have I told you using a for loop?
For loop.
Yeah. So here, how you will iterate for loop for this? Let's suppose I have to iterate on the grade. Then I will write for. Then I will use. So in this way you can iterate. I am printing the key and value. Okay. Let's just use the S interpolation. What we have seen. Can you tell me how I will print the key and value? Do you remember? Okay, we missed to close the braces, the double inverted comma. Okay, now if I print it, so it will give you key maths value 91, key English value 90.
Okay.
Okay, there is one more for each. We'll see about it. Okay, if you let's suppose that you have right, let's just hear what you have. if you want, let's suppose that you have datas, okay, and you want to iterate over it, then okay, let's just look at here only for the map. When I will teach you for each also. So for each is the other way of going to the for loop. For if you want to iterate on the each of the element, there are two ways: either use the for loop or use the for each. Okay, so let's suppose that here I have this, right, grade, and I want to print it or iterate it. So what I will do, dot for each, if I write like this also, it will iterate through all the element and will print it. We'll once we cover all this, we'll look at the for each also. Okay, so
Okay.
also instead of using the for loop, we are using for each in most of the places.
Okay.
Okay, okay, so these are the things in the map. What else we can see? Mhm. Adding element list and all we see, right? I think, yeah, that's it. There are, if there are other thing, you can look at it. Dot keys we saw, right? Max, mean, head, list, everything you can do on it. If you do the M string, then it will return you the string format. This, with this we have the map. Now let's just look at one more. You got the map, right? Or you have any question?
Yes, yes. I have it. I got it.
So map, when you will be using it, when you have key value pair. Okay, and one more thing, when you will be using the map, one more important thing is when you have to do the lookup. Lookup means, let's suppose that I have key value pair. Okay, and so now tell me what these will represent. What the output will be?
Set contains one. One list means one value will get.
Come again.
List contains one means one will be getting.
No, it will check whether it will contain the value 1 or not.
Okay.
Okay, so in both of the cases we will get the true. Okay, but given the situation which you will be using, okay, so whenever the you have to do the lookup of the elements, okay, that whether the element is present or not in the list or set, that time for the lookup and all you will be using set. Okay, it will be faster whenever you have to look up for the set. The representation is like it will be doing in the I'm not sure whether you know these things or not, that order of complexity. Do you know? Okay, so I told you to read the data structures and all, right, programming and all. If you do that, in that, if you try to learn those things, you will see the order of complexity and all. Okay.
Okay.
So actually in the set, if you try to check the elements whether present or not, okay, it will give you in the one sort, means in the order of one only, it will search it, that okay, whether one is present or not. But if you try to do into the list, it will take the n iteration, like it will check every element. It will go here, 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 and then it will check whether that element is present or not. So that's why we call it the order of n. Let's suppose if I want to check the 5, right, then what it will do, it will start from here and it will keep going, and then it will see that okay, 5 is present, return the true. But in the set, the representation is like it will use the hashing to store its value. Okay, because of that hashing, it will check in the only one in order of one. It's one time, you don't have to iterate all element. If you ask it whether 5 is present or not, it will directly check it here and it will give you the result. Yeah, it will check directly. It is using the some hashing algorithm to store its value. Okay, so because of that, it won't iterate one by one element. Okay, so it can reach, it will check into its data structure. It depends like how your elements are storing. Okay, so set will is to use the store the element in a way that you can access it very quickly. If you want to check whether element is present or not, okay, it will directly go and check you. For the lookup and all, you will be using the set. For
Okay.
the list, if you do the lookup on the list, it will also give you the result, but it will iterate through all the element. So that's why we call it its complexity is order of n, because it will look up for the n element. So it will keep searching. We are telling n because n is the maximum, right? Let's suppose if I ask it to search for 1, Okay, then it will just after 2 element only it will give you like order of 2, right? But if I ask you to give me the order of 5, fifth, then it will iterate through all the element order of 5, like means it will be order of 5. With order of 5 we mean that n element it has. So we write the worst, like what is the worst time it will take. Okay, so on the worst time it will take order of n. Do you understood these things or not?
Yeah, got it.
Okay, so a complexity for the list is order of n, and for the complexity for set is order of 1. So that's why whenever you have to do the lookup and all, you should use the set, not the list or vector array anything. So similarly, if you have to do the lookup of the key and all, okay, if you do the lookup of key in the map, it will be in order of 1. Okay.
Okay.
So let's suppose you have maps and you have multiple keys there. And if you try to look up for any key, it will be give you in the order of 1. Okay. So now, okay, it's it. Okay, tomorrow we'll read about the tuples, and then the fold left. Tomorrow the class will be a bit important because tomorrow we'll look at the reduce. Okay, and fold left. Okay, these are something which you need to understand because it is a bit difficult to understand things. Okay, like shorthand we are using here. We'll see it. Okay, tomorrow we'll try to finish these things, and from next class we'll start with the functions and all.
Okay.
Okay, so with the functions by Monday we'll start with the functions. So tomorrow we'll try to finish the all the whatever the collections and the operations are left. We'll try to finish those.
Yeah. Do we have a link where like the basic questions like for operators and
You
arrays?
just search about the Scala collections and operator. Okay, you will get all because in my slides also I have not kept all the operators and all. Okay, so
No,
if
no,
I
just for practicing
yeah,
questions.
you just search for Scala collection. Let's suppose you want to read the Scala list, right? Search for Scala list example operators operations.
Okay.
Okay, then you will give the give you will Google it. It will give you the some slides. Okay, or maybe it will take you to the Scala website or anything. For that, let me just tell you the website where you can read, right? Scala collection. Yeah, you can practice from these three websites. You can keep it. Just
Sure.
copy. Okay, practice on the ID. Maybe you can just start with any data structure and keep to practicing the plus, minus, and max, mean. And if you're using one more thing, if you're as you're using this IntelliJ, okay, if you give the dot, it will give you what all it is showing. You can see that what all collections or what all operations are available on it.
Okay.